You think you understand time. Hell, you're probably wearing a watch right now, aren't you? You feel yourself getting older with every breath. You remember what you had for breakfast yesterday, and you're already planning what you'll do tomorrow. Time feels obvious. It feels natural. It feels like the most fundamental thing in the universe. But here's the thing that's going to mess with your head. That's not time. That's just a sensation, a biological trick, a hallucination your meat computer calls a brain has been playing on you since the day you were born. Most people, maybe you're one of them, walk around with this beautiful poetic idea that time is like a river. You imagine it flowing majestically, carrying you along like a leaf from the murky waters of the past through the brief moment of the present and into the mysterious ocean of the future. It's romantic. It's intuitive. It's completely, utterly, catastrophically wrong. Here's the problem with that gorgeous metaphor that poets love so much. If time is a river, answer me this. How fast does this river flow? Think about it. Really think. 1 second per second? That's like saying a ruler is 1 ruler long, or a dollar costs $1. It's meaningless circular nonsense that tells you absolutely nothing about the nature of reality. It's the kind of answer that sounds profound at 2 a.m. when you're half asleep, but crumbles the moment you examine it in daylight. The truth, the real, honest-to-God truth, is much stranger than your wildest science fiction fantasies, much more mechanical than your romantic poetry, much more mind-bending than anything Hollywood has ever dreamed up. And honestly, a lot less comforting than that flowing river metaphor you've been clinging to. Time doesn't flow. Time doesn't push you anywhere like some invisible cosmic wind. Time doesn't pass any more than distance travels. And if you think you have a good grip on how time works, just because you can count seconds in your head, or because your smartphone tells you when you're late for work, buddy, you're in for the most spectacular intellectual faceplant of your life. Let's start with what's happening inside that 3-pound universe between your ears, because that's ground zero for this massive confusion about time. You think your internal clock, that little voice that tells you it's been about 5 minutes, is some kind of reliable instrument, like it's a Swiss chronometer precision engineered by evolution. It's not. It's a chaotic, jury-rigged mess of biological duct tape and evolutionary shortcuts that barely works on a good day. Here's an experiment that will blow your mind. Right now, try to count to 60 seconds in your head. Go ahead, I'll wait. 1, 2, 3. Just sit there and count like you're timing a soft-boiled egg. You think you're tracking time, but what you're actually doing is running a very specific, very personal, completely subjective mental program that has almost nothing to do with actual time. Here's where it gets fascinating and weird. Some of you, when you count, hear a voice in your head. You're literally having a conversation with yourself, sub-vocalizing 1, 2, 3, like there's a tiny announcer in your brain calling out the numbers. If someone interrupts you mid-count and asks you to speak, to say literally anything out loud, boom, you lose your place. The counting machine jams because you can't run 2 voice programs simultaneously. Your brain doesn't have enough bandwidth. But here's the kicker. Others of you, maybe you're one of them, don't hear a voice at all when you count time. Instead, you see something. Maybe it's a digital clock display changing numbers. Maybe it's an old-fashioned tape measure with numbers clicking past like a vintage stock ticker. Click, click, click. Maybe it's a mental number line stretching out in front of you with your consciousness sliding along it. And here's the absolutely mind-blowing part. If you're one of these visual counters, you can actually multitask while timing things. You can read a newspaper article, check your shopping list, organize your sock drawer, study the intricate patterns in your carpet weaving, solve a crossword puzzle, and still keep that mental chronometer running perfectly in the background. Your visual timing system operates independently of your language centers. But the voice counters, they can't read a single word without completely losing track of time. Their counting system hijacks the same neural circuits they use for language processing. This isn't just a cute neuroscience party trick. This reveals something absolutely fundamental about the nature of reality and consciousness that most people never think about. What you experience as the passage of time is nothing more than a mental construct, a pattern-matching game your particular brain plays with incoming data. It varies wildly, not just from person to person, but from moment to moment within the same person. It depends on your mood, your attention, your blood sugar, whether you've had coffee, whether you're bored or excited or terrified. It is not a universal constant carved into the fabric of reality. It's a biological hallucination, a useful one, sure. It keeps you from being late to meetings and helps you not burn dinner, but a hallucination nonetheless. So when we talk about physics, real physics, the kind that describes how the universe actually works rather than how it feels to live in it, we have to do something radical. We have to throw your brain out the window. We have to stop talking about how time feels and start talking about what time actually is. In physics, we have to be what we call operational. That's a fancy way of saying we don't waste our time asking mystical questions like, what is the essence of time? Or, what does time really mean? Those are questions for philosophy majors who enjoy arguing over overpriced coffee at 2 a.m. Instead, we ask the practical question, how do we measure it? And the answer is almost disappointingly simple, like finding out that the Wizard of Oz is just a guy behind a curtain. Time is just a way of ordering events, that's it. Full stop. End of story. It's a labeling system, a filing cabinet for the universe, a way to say, this happened, then that happened, then this other thing happened. Imagine you have a deck of playing cards. You lay them out in a neat row on your kitchen table. You can say the jack comes before the queen and the king comes after the queen. The cards aren't moving. The table isn't flowing like a river. Nothing is passing or elapsing. The order is just a structural property of how the cards are arranged in space. Time is the table. Events are the cards. When we say time passes, we're just reading the cards from left to right. When we say something happened before something else, we're just describing the order of cards in the deck. This brings us to the most catastrophic error in human thinking about time. An error so fundamental, so deeply embedded in our language and culture that most people never even realize they're making it. You think time is a container. You imagine the universe as this gigantic empty box floating in some kind of cosmic void, and time is like a grandfather clock on the wall of that box ticking away steadily. Tick, tock, tick, tock. Even if the box were completely empty, no stars, no planets, no atoms, no light, no energy, nothing but pure emptiness, you think that cosmic clock would keep ticking away in the darkness. Wrong. Dead wrong. So wrong it's not even in the same zip code as correct. This is what physicists call the Newtonian view, and it died a spectacular death over a century ago, though somehow nobody bothered to send most people the memo. Time is not a background stage where the cosmic drama unfolds. Time is not some invisible, intangible substance that exists independently of everything else. Time is not the theater. Time is part of the performance. Time is a measure of change, period. If absolutely nothing in the universe changes, and I mean nothing, no atoms vibrate, no light moves, no energy shifts, no particles spin, no forces act, then time stops, not slows down, stops, ceases to exist, becomes meaningless. You cannot define a second without a physical process to mark it. A swinging pendulum, a vibrating quartz crystal, a cesium atom oscillating between energy levels, the decay of a radioactive isotope. Time is not separate from the stuff in the universe. Time is a property of the stuff. This is where your intuition stages a full-scale rebellion. Every fiber of your being wants to argue with me. You want to say, okay, but surely time acts on things. Time ages me. Time makes my milk go sour. Time causes my car to rust. Time makes my flowers bloom. No, it doesn't. This is a linguistic trap that English, and every other human language, sets for us. Time is not an agent. Time doesn't have hands. It doesn't reach into your refrigerator and spoil your milk like some invisible cosmic gremlin. Time doesn't grab your face and etch wrinkles into your skin. Time doesn't sneak into your garage at night and rust your car. Bacteria spoil your milk. Chemical reactions etch your wrinkles. Oxidation rusts your car. Cellular division and DNA transcription make your flowers bloom. Time is just the bookkeeping system we use to track the rate at which those reactions happen. Saying, "Time did it," is exactly like saying, "Inches built the house." Inches didn't build anything. Carpenters built the house. Architects designed it. Concrete formed the foundation. Wood framed the walls. Inches just tell you where everything is located. Time is the ruler, not the worker. Now, let's push this ruler analogy further, because this is where things get really weird. Weird in a way that would make Alice in Wonderland feel like a perfectly sensible documentary. If time is just a ruler we use to measure the distance between events, like measuring the gap between "I put the egg in the pan" and "the egg is cooked," what happens if the ruler itself is flexible? What if the ruler can stretch and compress like a slinky? This isn't science fiction. This isn't some wild speculation from a physicist who's been hitting the espresso too hard. This is measurable, demonstrable, bet your life on it fact. We used to think, and by we, I mean every human being who ever lived before 1905, that a second was a second anywhere in the universe. If you had a perfect clock on Earth and an identical perfect clock on Mars, they would tick in perfect synchronization. Tick-tock, tick-tock, like two metronomes keeping the same beat across the cosmic void. It feels obvious. It feels right. It feels like the only sensible way the universe could work. It's completely, spectacularly, mind-bendingly false. The rate at which clocks tick depends on where they are and how fast they're moving. And this isn't some kind of mechanical problem with the clocks, like they need oil or their gears are worn out. This is a fundamental feature of reality itself. Space and time are woven together into a single fabric, and that fabric can be stretched, compressed, twisted, and warped. Here's an analogy that might help your brain process this cosmic weirdness. Imagine you're driving a car across a giant, perfectly flat sheet of paper that extends infinitely in all directions. You can steer north, or you can steer east, or any direction in between. Your car has a cruise control that's locked at exactly 60 miles per hour. You can't go faster or slower, no matter what. If you drive purely north, you're making maximum progress in the northward direction. You're covering 60 miles of northward distance every hour. But if you turn your steering wheel and start driving northeast, you're sharing your speed. You're moving a bit north and a bit east. You're still going 60 miles per hour total, but you're not going north as fast as you were before. Maybe now you're only covering 42 miles of northward distance per hour because you've diverted some of that motion eastward. The faster you go east, the slower your progress north becomes. If you turn completely east and floor it, you're making zero northward progress even though you're still going 60 miles per hour. Now replace north with time and east with space. This is the essence of Einstein's relativity, and it's going to melt your brain like ice cream on hot asphalt. You are always moving through the universe at a constant speed. Always. This speed, call it your space-time velocity, is locked in at exactly the speed of light. You can't go faster, you can't go slower, you can't stop. But here's the kicker. That motion is shared between movement through space and movement through time. If you're sitting perfectly still in your chair right now, not moving through space at all, you're dedicating 100% of your motion to moving through time. You're traveling into the future at maximum speed, 1 second per second. You're aging at the normal rate. Your watch is ticking at its normal pace. But the moment you stand up and walk to the kitchen, or hop in your car and drive to work, or climb aboard a rocket ship and blast off to Mars, you're diverting some of that motion away from time and into space. You're moving through space, which means, mathematically must mean, that you're moving slower through time. Your clock slows down. Your aging slows down. Time dilates. You're not breaking the universe. You're not cheating physics. You're just changing direction on the space-time highway. If you could somehow accelerate to the speed of light, which you can't because you're made of matter, and matter can't reach light speed for reasons we'll skip for now, you would be using 100% of your space-time motion for space. You would have zero motion left over for time. For a photon of light, time does not pass. At all. Ever. A photon is created and absorbed in literally the same instant from its own perspective, even if that photon traveled across the entire observable universe for 13.8 billion years by our clocks. For the photon, the universe is frozen, static, a single moment that never changes. This isn't poetic metaphor. This is mathematical fact. Now, you might be thinking, okay, that's fascinating in a cosmic sense, but I don't feel my watch slowing down when I jog around the block or drive to the grocery store. Of course you don't. You're biological molasses. You're a turtle in the cosmic speed Olympics. The fastest you've ever moved in your entire life, maybe 80 miles per hour on the freeway, is pathetically slow compared to light speed. The time dilation effects are absolutely tiny at human speeds, but they're real. We have to program GPS satellites with Einstein's math. These satellites are orbiting Earth at about 8,700 miles per hour. That's fast by human standards, but still snail-like compared to light speed. Nevertheless, their clocks run slightly slow compared to clocks on Earth's surface. If we didn't account for this relativistic time dilation, your GPS would be off by miles within a single day. Every time you use your phone to navigate to a restaurant or find the nearest gas station, you're relying on Einstein's crazy theories about time being relative and flexible. The proof is literally in your pocket. But there's another aspect of time that tricks our brains, and it brings us back to that pattern recognition problem we talked about earlier. We perceive time as having a direction, an arrow, a flow from past to future that feels as real and obvious as water flowing downhill. The past is fixed, crystallized, unchangeable. You can remember what you had for breakfast, but you can't change it. The future is open, uncertain, full of possibilities. You can't remember what you'll have for dinner tomorrow, but you can influence it. This feels so natural, so fundamental, that questioning it seems insane. But here's the thing that should keep you awake at night. If the fundamental equations of physics work equally well forwards and backwards, and most of them do, why can't we remember the future? Why does time seem to have this built-in directionality? Think about it. If you film a planet orbiting a star and play the movie backward, it looks perfectly normal. The planet follows exactly the same orbit, just in reverse. All the laws of gravity work perfectly. The math checks out. But if you film an egg falling off a table, splattering on the floor, and then play that movie backward, everyone immediately knows it's fake. The yellow yolk doesn't spontaneously leap off the floor, magically reassemble itself into a perfect sphere, and seal itself inside a pristine white shell. That would be absurd. Here's the secret that explains everything, and it's going to change how you see the entire universe. This directionality isn't about time itself. It's about probability. It's about disorder. It's about the most fundamental principle in all of physics, entropy. Breaking an egg is easy, ridiculously easy. There are literally billions upon billions of ways for an egg to be broken. Shell fragments scattered here, yolks splattered there, white spread in puddles, pieces flung in every direction. The egg can break into 3 chunks or 3,000. The yolk can end up on the left side of the floor or the right side. The shell can crack in zigzags or spirals or random patterns. But there's only one specific arrangement where the egg is whole and perfect. So as things move around and bump into each other and interact, as the universe does its thing, they naturally stumble from highly organized states, few possible arrangements, toward disorganized states, many possible arrangements. We call this increase in disorder entropy, and it's the closest thing physics has to an absolute law. And this is the only reason you feel an arrow of time. You're not actually sensing time flowing. You're sensing the universe getting more disordered, more chaotic, more scrambled. You're a disorder detector. Imagine the universe started as a perfectly ordered deck of cards, every suit and sequence, aces through kings, arranged with mathematical precision. And every second that ticks by is just the universe shuffling that deck a bit more. You can't unshuffle a deck just by wishing. You can't decrease entropy just by hoping really hard. The cards don't spontaneously organize themselves back into perfect order any more than broken eggs spontaneously reassemble themselves. When you distinguish past from future, you're really just distinguishing less messy from more messy, more organized from less organized, lower entropy from higher entropy. If the universe were somehow in a state of maximum mess, maximum entropy, where everything was perfectly evenly distributed and nothing interesting was happening anywhere, your brain wouldn't be able to tell past from future. There would be no eggs to break, no patterns to form, no memories to encode. In such a thermal equilibrium universe, the arrow of time would vanish completely. Now let's circle back to those people counting seconds in their heads, the voice hearers versus the tape measure seers. They're both struggling with the same fundamental problem, trying to impose a rigid linear structure on a universe that is actually much more flexible and strange than their brains can naturally comprehend. We build these mental models, these internal chronometers, because we desperately need them to survive. We need to know when the predator is coming, when the fruit will ripen, when winter will arrive, when our children will be born. We evolved sophisticated timing mechanisms because accurate time perception meant the difference between eating and starving, between reproducing and dying childless. But we did not evolve to understand the dimension of time. We evolved to track duration, to estimate how long in practical survival-relevant terms. Our brains are optimized for efficiency, not accuracy. We focus obsessively on the present moment because that's where we live, where we make decisions, where we avoid danger and find food and mates. But in physics, now is a very slippery concept that would make a philosopher of language weep with frustration. If you and I are standing next to each other in the same room, our definition of now is effectively identical. We agree on what's happening right now to within a tiny fraction of a second. But if you hop on a spaceship and travel to a planet a million light years away, and then start walking away from me at a brisk pace, something mind-bending happens. Your definition of now slices through the universe at a slightly different angle than mine. What you consider to be happening right now might be in my future. What I consider to be happening right now might be in your past. There is no universal now that blankets the entire cosmos like a synchronizing signal. The universe isn't like a movie theater where everyone watches the same frame of the film at the same time. The universe is more like a four-dimensional loaf of bread, a space-time loaf, and how you slice that loaf depends entirely on your motion through it. This is incredibly hard to grasp. It feels wrong on every level. It feels like I'm telling you that up is down, that black is white, that 2 + 2 = 5. That's because you're trying to translate the high-level language of the universe, the language of mathematics and physics, into the low-level language of your biology, your evolved intuition, your monkey brain that's optimized for swinging through trees and avoiding saber-toothed tigers. You're trying to count cosmic socks when you should be measuring light beams. When you try to force the universe to fit your intuition, you get confusion, you get paradoxes, you get the feeling that physics is just elaborate academic nonsense designed to make professors feel superior. But when you let go, when you stop trying to count time like a pile of laundry and start measuring it like a dimension of space, suddenly everything clicks into place. The equations work. The universe makes sense. GPS satellites function. Particle accelerators operate. The predictions match the experiments with breathtaking precision. We're not done yet, though. Even if we accept that time is a flexible dimension that stretches and contracts with motion, even if we acknowledge that the arrow of time emerges from entropy rather than some fundamental cosmic flow, there's still a much deeper question lurking in the shadows. What about the beginning? We've talked about measuring time, and we've talked about the arrow of disorder, but we haven't tackled the ultimate puzzle. If time is a measure of change, what happens when you run the cosmic movie backward all the way to the very first frame? The universe is expanding. Every galaxy is moving away from every other galaxy. If we wind this expansion backward like rewinding a video, everything gets closer together, smaller, denser, hotter. Eventually, you hit a point about 13.8 billion years ago where all the matter and energy in the observable universe was compressed into a region smaller than the period at the end of this sentence. The temperature was infinite, the density was infinite, the curvature of space-time was infinite. At that moment, which we call the Big Bang, the laws of physics themselves start to melt like wax in a furnace. This is the ultimate test of your new understanding of time. All our clocks, atomic clocks, pendulum clocks, quartz watches, radioactive decay, stellar evolution, everything we use to measure time, exist inside the universe. They're made of the same matter and energy that emerged from the Big Bang. But if the universe itself was born in that moment of infinite density and temperature, does it even make sense to ask what happened before that? Using our new definition of time is a way of ordering events within the universe. Asking what happened before the Big Bang might be as nonsensical as asking what is north of the North Pole. It sounds like a perfectly reasonable question grammatically. The words are arranged properly. The grammar is correct. But geometrically, mathematically, it's complete gibberish. There is no north of the North Pole because north only has meaning within the coordinate system of Earth's surface. Once you reach the pole, the concept breaks down. Similarly, there may be no before the Big Bang, because time itself only has meaning within the context of our universe. And yet, despite all this careful reasoning, we still have that nagging feeling. That internal voice counting 1, 2, 3. We desperately want the universe to have a backstory, a prequel, what came before that extends backward forever. It's almost impossible to accept that the cosmic tape measure might simply start at 0, that the counting machine had an on switch with nothing before it. This creates a profound friction between our psychology and our cosmology. We are finite beings with finite lifespans trying to comprehend the infinite using tools made of meat and electricity and evolved chemistry. It's honestly a miracle we understand anything at all about the universe beyond our immediate sensory experience. Remember the different counting patterns we discussed earlier? The person who hears a voice counting versus the person who sees a visual tape measure? They're using different mental circuits, auditory versus visual processing, which is why the visual counter can read while timing, but the auditory counter cannot. Physics works the same way. Classical mechanics, Newton's laws, the physics you learned in high school, was like the auditory counting system. It worked beautifully for everyday human-scale stuff, throwing balls, building bridges, launching cannonballs, predicting planetary orbits. But when we encountered situations involving very high speeds, very strong gravitational fields, or very small scales, the old system started giving us wrong answers. We needed an upgrade. Relativity and quantum mechanics are like switching from auditory counting to visual tape measure counting. They allow us to process complex patterns and relationships that the old way of thinking simply couldn't handle. The upgrade process is painful. It requires discarding cherished ideas like absolute time and deterministic predictability. But it works. We're constantly upgrading our mental software to match the hardware of reality. Here's the beautiful paradox that should fill you with wonder rather than despair. Even though your intuition about time is wrong, even though your internal chronometer is a biological hack running on jury-rigged wetware, even though time is actually a flexible, relative, bendy dimension rather than the steady metronome you imagined, it still works perfectly for your daily life. You can still boil an egg without burning it. You can still meet friends for coffee at 2 p.m. You can still catch flights and make appointments and watch movies and celebrate birthdays. The weirdness of relativity is hidden under the hood of reality like the engine of a car. You don't need to understand internal combustion to drive to work. and you don't need to understand space-time metrics to live a perfectly functional, productive, happy life. But isn't it better to know? Isn't it magnificent to realize that the universe is far stranger and more wonderful than our monkey brains could ever have imagined? This brings us full circle to that experiment with counting. The profound difference between people who hear numbers and people who visualize them isn't just a cute neuroscience curiosity. It reveals something terrifying about human communication and understanding. When two people have a conversation about something complex, time, consciousness, love, justice, beauty, they think they're speaking the same language. They nod in agreement. They smile and say, "I totally understand what you mean." But what's actually happening under the surface is far more chaotic. You're running a massive invisible translation scheme. You take the words I say and convert them into your private internal imagery, which might be completely, utterly alien from mine. I say 1 minute, and I might see a clock face with hands sweeping around. You hear those same words and experience a voice in your head saying 60 seconds. We arrive at the same practical answer. We both show up on time, so we assume we're having the same experience. But the mental machinery, the actual cognitive processes, might be as different as a bicycle and a helicopter. This matters for physics education because it exposes the incredible fragility of what we call common sense. Common sense isn't some reliable guide to truth. It's just the collection of prejudices and assumptions you accumulated by age 18, built on your particular internal imagery and limited experience. If your mental model of time is a tape measure with numbers clicking by, you'll struggle to understand how time can bend and stretch. If your internal time experience is auditory, of voice counting, you'll find it nearly impossible to grasp how time can be spatial, geometric, something you can visualize and manipulate mathematically. When physics teachers try to explain quantum mechanics or the curvature of space-time or the relationship between matter and energy, we're not just giving you new facts to memorize. We're asking you to perform brain surgery on yourself. We're asking you to delete your cognitive operating system and install a completely different one. We're asking you to throw away the tape measure, silence the internal voice, and rebuild your entire conceptual framework from scratch using alien mathematics and counterintuitive principles. And that's why it feels so impossibly hard. That's why your brain rebels and rejects and insists that the physics must be wrong because it doesn't match your experience. You're not just learning new information, you're translating against the grain of your own biology, fighting against millions of years of evolution that optimized your brain for a very different kind of problem solving. But here's what I find absolutely amazing. Despite all these limitations, despite the fact that we're biological creatures trying to understand a universe that operates on principles completely alien to our everyday experience, we've still managed to figure out incredible things. We've measured the age of the universe. We've detected gravitational waves from colliding black holes billions of light years away. We've built machines that can manipulate individual atoms. We've created technologies that would seem like pure magic to people just a century ago. We've learned that time is not what we thought it was. And in doing so, we've gained a deeper appreciation for just how strange and wonderful reality actually is. The universe doesn't owe us the courtesy of being intuitive. It doesn't have to make sense to our monkey brains. The fact that we can understand it at all, even partially, even with great effort, is perhaps the most remarkable thing of all. So the next time you glance at your watch, remember, you're not just checking the time. You're glimpsing one of the deepest mysteries of existence itself. Time isn't just ticking away, it's bending, stretching, connecting space and matter and energy in ways that would have seemed impossible just a few generations ago. And that, I think, is far more amazing than any flowing river could ever be.